Hey GED students, it's GED question of the daytime. And some people think I'm silly for asking you guys basic questions like this. Let's take a look. It says, which of the following is the best way to set up the expression 76 plus 576 in order to perform the addition algorithm? And I mean the standard addition algorithm. It's not the only way to add, but it's how most of us add with this up-down vertical method like this, lining things up, putting that plus sign under there. And I want you to justify your answer. I want you to tell me why. Reason for this. I've got a reason. I'm not being silly. I know that 99% of the students that pass through my door can line up this problem properly. The issue, though, is when I start moving on to decimals or fractions or algebra and we go to add, they suddenly don't know what to do. And I argue that if you knew why you were doing what you were doing on this problem, you wouldn't struggle with adding decimals, adding fractions, adding algebraic terms, we call that combining like terms, any of those skills half as much as you do. So let's take a look here. Well, a lot of students say, oh, Kate, I know which one's the best lineup. It's this one. Whoa, sorry. Okay, so they're like, oh, the middle one for sure, middle one for sure. But the interesting thing is when I ask them why, although some students don't even like the middle one, some students tell me none of my answers are right. You should have put the bigger number on top and the smaller number on the bottom and lined them up that way. And I have to say to you guys, for those of you who are so focused on putting the bigger number on the top, you may do that for ease and normalcy, but it actually doesn't matter. Those two answers will give me the exact same, or those two problems will give me the exact same answer. Order doesn't matter in addition. Let me say that again. Order doesn't matter in addition. It doesn't matter which one's on the top and which one's on the bottom. Some of you guys are getting focused on the wrong things, okay? So those two are interchangeable. But what students tell me is the reason why it has to look like this one I wrote on the left here or this one I wrote on the right here is they tell me, well, numbers have to line up at the right. That's what they tell me. I better have my two numbers lined up here on the right. And I absolutely disagree with you. That is a lie. If you believe that, you're the student who struggles with decimals. Why do we line up the numbers the way we do? We do it because of one super duper important math concept that will carry you from the most basic addition problems like this to the most complex addition problems you will ever see. And that is this. You can only add and subtract the same kinds of things. I'll say it again. You can only add and subtract the same kinds of things. Now you might be saying to me, Kate, these are all the same kinds of things. It's a number and a number. What the heck are you talking about? Not exactly. Not exactly. If I have a number like this, 6, let me not do 666. I'll scare the whole internet. Let me do 333. I have a number like this, 333. There are 3 3s in that number, but they're not all the same, are they? This first one here is in the ones place. That's like having 3 $1 bills. That's a real big difference from having this 3. That 30 is actually 3 10s. It's like having 3 $10 bills. And this 3 over here would be in the hundreds place. It'd be like having 3 $100 bills. So when we go to add, the reason why we have it lined up the way we do is we need to make sure that ones line up with ones. We're going to add ones with ones. That tens add up with tens. We're going to add tens with tens. And then, of course, we didn't have any hundreds in the first number, but we do in the second number. We would have any hundreds line up with hundreds. That's the whole reason we line up the way we do, because you can only add and subtract the same kinds of things. This is this really basic concept of addition that will carry you through to the hardest problems. Now let's go ahead and add it. Might as well. We're here already. Correct answer to this was the middle one. Why? Because I had everything lined up according to place value. Okay, that's the answer. But let's go ahead and add it and think about what happens. If you add 6 ones and 6 ones, of course you end up with 12 ones. But you may have noticed we don't write a 12 down there in the ones column. Instead, we write a 2 here and a 1 here. Why? Well, think about what 12 means. 12 means one group of 10, and 2 ones. So I carry the one group of 10 in the tens column, and I drop the 2 ones there. Now let's keep trying that same idea here. So what does it mean to have 2 sevens in the tens column? It means I have groups. Think of the stick And don't count my squares because don't have a lot of space to work. But think of this deck like 10 ones at once. That's 110. And I have 110 7 times. And I have another 7 tens. We know that's 14 tens. And then I'm going to carry the 110 from before. So now I have 15 tens. Well, what is 15 tens? Well, if you think about it, you can group 10 tens together. And 10 tens is a group of 100. A group of 100, so I carry 1 in the hundreds column. And then how many do I have left over here? I have 5 ones. So when you think about 15 tens, or I shouldn't say 5 ones, it's 5 tens. That is the same as 5 tens and 1 100. Again, 15 in the tens column means I have 5 tens. 1, 2, 3, 4, 5, and 100, a group of 100. 10 tens is a group of 100. And now I can add up my hundreds. If I have 100, and 5 100s, I have a total of 6 100s. And that is why we add the way we do. It's not just a bunch of gobbledygook steps that your math teacher taught you because she loves to teach you steps. There's a real reason for the algorithm and the way that it behaves. All right, if you have any questions about this or any other math concept, just drop it in the comments and I'll do my best to answer it.